Today we're looking at another Meta and Facebook tag problem. This one is Leetcode 921, minimum add to make parentheses valid. So this question reads that a parentheses string is only valid if we have the following conditions. If the string is empty, if it can be written as A and B, where A and B are both valid, or it can be written as A, where A is a valid string. So the way they lay this out is a bit confusing, but let's just kind of draw out what exactly a valid string looks like. So a valid parentheses string could either be an empty string, like they said, or for every opening, there has to be a closing, right? So this is a valid parentheses string because there is one opening and one closing. If we had something like this, this is not valid because even though this part is valid, this opening here has no corresponding closing, so this is invalid. Another example is that a closing has to have an opening that came before it. So this is not a valid string, but if we had this or any combination where these have to be matched, right? So basically the rules are one, an opening must have closing, and then likewise we can't have more close than open at any given point, right? So we have to make sure that all our opens are matched with the close, but also that we can't have closed that are unmatched by an open. So let's walk through a couple examples and see how we can figure this out. So there are three examples here. We're going to walk through each one. The things that we want to keep in mind is a concept that we're going to refer to as the balance, right? So we're going to keep track of the balance of each of these strings as we go through it. And the way we're going to do that is for an open parentheses, we're going to add one. And then for a close, we're going to minus one. And you'll see exactly how this is going to work. So when we have a zero balance, this means that our string is perfectly balanced. Everything's great at this point. If we have a positive balance, what this means is that we have more open than we do closed. If we have a negative balance, that means we have more closed than we have open, right? So a lot here. Let's kind of walk through these examples and see exactly what this looks like. So here, let's start with this example here. So we're going to go through each character and keep track of our balance. So here we see this open, so we're going to add 1 to our balance. So now 1 is our current balance. We get to the second point, we see a close, and then we're going to subtract 1 from our balance. So at this point we see 0. Our string is perfectly balanced. So let's go to this third character, and now our balance becomes -1. So when we see a negative, what does this mean? We know that if our balance ever goes to -1, we have to remove whatever closing bracket we have, right? Because there's no way that we can include this because there was never a previous opening that we can match it with. So let's remember here that if we ever see a -1 while we are going through and keeping our balance, then we know we have to remove it. So what do we do in this case? Well, what we can do is say our balance is 1, so let's also have a variable that says to remove. So we see -1, we know we have to remove it, so we can make this 1, and then what we're going to do is say we removed it, so we don't count this in our balance anymore since it's gone, so we just change our balance back to 0. So what you can get from that example is that if our balance ever becomes negative, we just remove it, keep track of how many we have to remove, and reset our balance back to 0 and deal with the previously balanced string that we have. So that's one example. Let's look at this next example, which is 3 opening brackets. So here, pretty straightforward what will happen here. We go 1, our balance is 1, second, balance becomes 2, third, balance becomes 3. So what do we do when we end with a positive, right? So you might be thinking, well, the balance is a negative, so we do have to do anything. Well, remember we discussed that all the opening brackets, they have to be matched by a closing bracket. Having just a bunch of open brackets without anything closing them is not valid. So essentially what we do is we have to also consider what we have left open, and we have to add some amount to offset this, right? So how do we offset 3 open? Well, we need 3 closed. So we'd have to add three closed parentheses to offset this. So what do we do here? So here we have the first, our balance is -1. Let's keep track of our to add here. So we see we have -1. We know we can't have a negative balance, so we get rid of this. Our balance becomes 0. We add 1. We go to the second. We subtract 1. We see a negative balance. We can't have that, so it becomes 0. To add becomes 2. And I think you'll know what happens to the third one. Same thing. We make -1 our balance. We make it 0. Add 3. So we went through a couple examples that kind of illustrate all the possibilities that can happen. And there are just basically 2 general things we want to remember when solving this. So 1. So whenever we have a negative balance, we will have to add and reset our current balance to 0. So whenever we have negative balance, we know we have to add 1. And then 2, if we have a positive balance at the end, we have to offset them. So say that our balance at the end equals 2. This means that we have 2 open brackets that we have to close at this point. So we need to add this value to the total number we need to add. So at the end, what we actually want to return is just the number that we found we have to add, so to add, and we'll get these from removing when we have negative values, but then also whatever is left at the end, and we just return this as our final answer. And we can do this in O of n time. We're just going to the string 1 time, and then O of 1 time complexity, since we're using no extra space to do this. So let's look at the code and see exactly how we can solve this. So the first thing we're going to do is set up those 2 variables that we use to track our balance and also how many we have to add. So then we just iterate through all the characters in our string, and we see if our character equals an open bracket, then that means that we add 1 to our balance, otherwise we subtract 1. So here's the important step. If our balance is ever less than 0, this means that we've encountered more closing brackets than opening brackets. So in this case, we know that we have to add at least 1 to offset whatever that negative balance is, and then we can reset our current balance to 0 because we can assume that we've added that opening bracket and our string is back to being balanced. So at the end, we just return how many we found that we have to add plus whatever our current balance is. And this current balance will always be positive or 0. And if it's positive, it means we have opening brackets that we still have to match. So let's submit this and make sure that it works. And it does. So this is a pretty good parentheses problem. Definitely good to understand these, especially if you're studying for a Facebook Meta interview. So hopefully this is helpful, and thank you for watching.